Good morning. So I am Dr.P.Ponesakkiraja, so Associate Professor from PSN College of Engineering and Technology, so Department of Mechanical Engineering. So now I am explaining about the manufacturing process. So what is meant by manufacturing process? So manufacturing is the process of converting raw materials into products. So what type of product are to making by using the manufacturing process? Here the manufacturing process, various types of process is there. So there are two major types of manufacturing processes available. First one is metal removal process, then second one metal non-removal process. So what is meant by metal removal process? So metal removal process means by using the lathe, then milling operations, then drilling operations, etc. That is the metal removal process. So metal non-removal process means, for example, forging operations, then drawing. This is a metal non-removal process. So types of metal non-removal process: forging, then drawing, then extrusions. And types of metal removal process: lathe, milling, drilling, so grinding, etc. This is the metal removal process. Then the joining process by using the weldings. Here the various types of welding is available. First one is gas metal arc welding. So that is MIG welding. So MIG welding is a simple, popular form of welding. A novice can operate and master the art easily. MIG stands for metal inert gas and sometimes may be called gas metal arc weldings. It is a semi-automatic and quick process where filler wire is fed through the gun and shielding gas is expelled around to protect from environmental impurities. The filler wire is fed on a spool to act as an electrode as well. These welding types are sensitive to external factors like rain, wind and dust, making them not great for outdoor use. The quality problem with MIG welding includes rust and porosity to make the structure weak. The commonest use of the MIG welding process is in automotive, repair, construction, then plumbing, then robotics and the maritime industries. The welding offer is steady, strong and can withstand enormous force. Then next one, shielded metal arc welding. These are century-old types of welding process and improve regularly from time to time. It is popular welding because of its low cost and easy and simple operability. The process comes with spectral welding that needs cleanup. Essentially, the filler material here is a replaceable stick electrode. It generates the arc when the end of the stick contacts the base metals. The heat of the arc melts the electrodes, filler metal to make the weld. It coats the stick electrode with a flux that creates a shielding cloud to protect the weld zone from oxidation. The flux on cooling changes into slag, which needs to chip off. Then next one, TIG welding. It is a gas tungsten arc welding. TIG welding is possible with no filler materials. The non-consumable tungsten electrode is used to create the arc. When conducting the base metal, the strong arc melts the two metals and join them. You may use filler wire if required. We need a constant supply of shielding gas to protect welding from environmental impurities. It works better indoors and away from the elements. This is the diagram of the TIG weldings. Then flux coated arc welding. The type of welding is similar to MIG welding, as a power source can perform both types of welding. MIG welding needs filler wire working as an electrode feed continuously from the gun. Conversely, flux coated arc welding has a wire with its core as flux and creates a gas shielding zone around the weld. No need for any external shielding gas in this welding type. The process is versatile and works thick metals. This is the diagram of the welding. Then next one, submerged arc welding. The types of welding involve the conveying of metal pieces, welding wire and arc, and welding joint by a blanket of flux. It makes the process safe as there are no emissions of welding fumes, strong arc lights and flying slags. The flux barrier protects the human and robot whosoever is performing the welding. It is a faster process for high production industries. SAW produces strong welds with deep penetration with minimal preparation quickly and efficiently. It protects the welder from UV light and infrared radiation because of the flux layer. Then gas welding, oxidous clean welding. So one of the hottest method of welding at 3500 degrees Celsius. The temperature of welding have reached 7 times as hot as the biggest, hottest piece of oven. It generates heat when a mixture of fuel gases and oxygen passes in a torch. The process involves 3 types of flames. There are natural flame, then carburizing flame and oxidizing flame. The advantages of the welding process are many. It is portable because of pressurized gas filled in a hand distilled cylinder. It is fairly easy to use and versatile for different sizes of metals. It is a very safe and economical option where a nurse can perform easily. This is the diagram of the gas welding. It is the 2 types of gases which are used. One is acetylene, then oxygen. next one, thermite welding. When thermite is a mixture of aluminium powder and iron oxide is ignited, it leads to an exthermic reactions non-violent. The excessive heat melts the metal and cures at the needed joint surface. The liquid metal solidifies on cooling to create a solid welding joint. It is a simple and fast method to join similar and dissimilar metals. This welding process does not need any power supply. The only need is to heat the thermite at 1300 degrees Celsius. Then fork welding. This is the oldest welding technique. When we were questioning what welding is, this technique is answering for centuries. The metal had heated to a malleable state which hammered into the desired form and finally cooled to set the shape. The process came into mind while a blacksmith working on metal. It is not limited to these professionals only, but forge welding happens to be a choice in the aerospace industry. The process needs a skilled user but is a popular choice as there is no need for any filler metals. Then next one, electron beam welding. Find the ray of high velocity electrons at the welding metal involves this type of welding. The energy from the electron transfers to the sheets to melt the welding metals, which can be joined and fused. This type of welding is employed in multiple industries like automotive parts and high-end aircraft engine industries. This can be a useful tool in aerospace components. Bimetal saw blades and transmission assemblies. It is a perfect choice to shield electrical components. The technique is good for dissimilar metals of various melting points and thermal conductivities. This welding method is good for thin and thick metal. Then automatic hydrogen welding. This type of welding process is replaced now by MIG welding. Now in most indications it is still a perfect choice for tungsten welding. This metal is heat resistant, but by this method you can fuse without altering the metal when joining and welding them. They place the two metal tungsten electrodes in a hydrogen atmosphere. The hydrogen molecules in explosive heat can produce heat up to 3000 degrees Celsius. The proper safety precautions like welder gloves, shoot, then gloves and helmet are essential. The next one, plasma arc welding. A newer technique was developed in 1954 and is similar to TIG welding. They pass the electrical current through an orifice of the nozzle protected by gases for the ultimate accuracy to weld a small area. It produces a narrow bed playing well and strong and speed welding. The method used an extremely high temperature for a deep and stronger weld. The aircraft industry used these techniques but not of any use to harvest and diffusers. Then resistance welding. This is a thermoelectric process where electric resistance is employed to create heat, leading to a molten state of material being joined. The efficient welding process is pollution free with minimum electricity consumption as well. It used two electrode in spot welding where the tip of the electrode produces heat and fusion and cooling. The following area are the different types of welding: spot welding, seam welding, projection welding, flash butt welding. And casting. This is casting. Casting is one type of manufacturing process. Here various types of casting process is available. Then casting is a process of pouring liquid metal in a mold containing the hollow shape of the desired outcome. It uses spur gates and runners to pour the metal. The main type of manufacturing process under casting area: centrifugal casting. And centrifugal casting is a process of pouring molten metal into a spinning die. The spinning die creates high forces to the molten metal, which gives it the cylindrical shape. Moreover, spinning let the impurities to float the inner dia, from where it is removed later. Spinning can either be on a vertical and horizontal axis depending on the configuration of the desired part, such as vertical rotation is used to cast ring and cylinder, and horizontal rotation is used to cast tubular shapes. Die casting. So die casting is a manufacturing process used for producing metal parts where high precision is required. This process is accomplished by forcing molten metal under high pressure into resolvable metal dies. High volume production is done using this process. Steel molds capable of producing several castings at once are produced. So molds are mounted securely in a die casting machine and are arranged so that one is stationary while the other is mobile. The die cavity is injected with molten metal and allowed to solidify, and the part is ejected. Example, die casting process is used for producing non-ferrous metal parts. Some examples of die casting include engines, clutch housing, and covers of four-wheeler vehicle. Sand casting. Sand casting is metal casting process that uses sand as the mold material. This process has a low production rate as the sand mold must be dissolved in order to remove the part. So although it is a cheap process when low volume production is required. Then process is furnace and metal and pattern and sand mold are used in the sand casting process. The molten metal is poured using ladle into the cavity of the sand mold, which is made from the pattern. The casting is allowed to solidify and then removed by breaking the mold. For example, more than 70% of all metal castings are produced by sand casting process. Some example of sand casting process include engine blocks, machine tool bases, cylinder head and pump housing and valves, then gears, then pulleys, then crankshafts, then connecting rods and propellers, etc. The permanent mold casting. Permanent mold casting is a manufacturing process that offers visibility of metal molds, which makes it eligible for high volume production. This process uses gravity or vacuum or gas to fill the mold process. The mold is preheated and a ceramic coating is applied to the mold cavity surfaces to facilitate part of removal. The molten metal is poured from a ladle and gravity or vacuum is used to raise the molten metal into the mold assembly. The casting is allowed to solidify and then removed by opening the mold assembly. For example, some examples of permanent mold casting include gears, pipe fittings, then fuel injection housings, then spines, wells, then gear housing, then engine pistons. Investment castings. Then investment casting is metal casting process of pouring molten metal into an expandable ceramic mold. This process is also known as last wax casting, as the wax pattern is melted out of the mold. When molten metal is pure, then complex parts are made using this process. This process is the wax pattern is prepared and invested by the ceramic slurry, then harden it and converts it into a mold. The mold is preheated to evaporate the wax and the molten metal is poured from a ladle into the mold. The casting is allowed to solidify and then the mold is broken and the casting removed. For example, some examples of investment casting include turbine plates, then aeroplane parts, then firearm, then components and military equipments, etc. Then shield molding. Shield molding is a metal casting process that uses a sand convert with resin to form the mold. This process is similar to sand casting process but has better dimensional accuracy and higher productivity rate and lower labor equipment. Also, the shield molds are resolvable and expandable. The process, a two-piece metal pattern is created in the shape of the desired part using iron or steel. These patterns are clamped to a dump box containing the mixture of sand and a resin binder. This is known as shield preparation method. These shields are joined together and clamped to form the complete shell mold, and the molten metal is poured from a ladle into the mold cavity. So after the casting is solidified, the mold is broken and the casting removed. Example, shield molding is used for producing high precision parts. Some example of shell molding include gear housing, then cylinder heads and connecting rods and lever arms, etc. And molding is a manufacturing process that uses a rigid frame to shape hot liquid or a ductile raw material. It is mostly used to manufacture plastic products. The different type of manufacturing process under molding. Then next one, injection molding. Then injection molding is a molding process used for producing parts by injecting molten material into a mold. It is the most commonly used molding process for manufacturing plastic parts. This process requires the use of an injection molding machine. raw plastic pellets and a mold to get the desired output. The plastic is melted in the injection molding machine with the help of heaters, and then a rotating reciprocating screw injects it into the mold, where it cools and solidifies into the final part. Some example of injection molding include automotive parts and components, game toys, chairs, tables, storage containers, housing for applications, consumer electronics, because etc. Then blow molding. So blow molding is a molding process used to manufacture hollow plastic parts. This process starts with melting down the plastic and forming it into a person. The person is then clamped into a mold and air is blown into it. This air pushes the plastic out to match the mold. The plastic is allowed to cool and later the mold open and the part is ejected. Although the blow molding process is costlier than injection molding, it is still used for manufacturing many plastic products. Blow molding is divided into three types of manufacturing process, namely extrusion blow molding, injection blow molding, and injection stretch blow molding. Some example of blow molding include automotive ducts, then stadium seating, chairs, containers, trays, and reservoirs, tanks, coolers, then fan housing, panels, doors, then toys, etc. Then the watering cans and housing product carrying cases. In extrusion molding. An extrusion molding is a process used to manufacture long, tube-shaped products of a fixed cross-section. This process uses an extrusion machine to force the heated plastic through a die with an opening. The machine uses a reciprocating rotating screw to feed the plastic into the die. The die then forces the material into the desired shape or the shape of the die. Heaters are used to melting the plastic in the extrusion machine. The material is allowed to cool and then cut down into the required shape. Rotational molding. Rotational molding is a molding process used for manufacturing hollow parts. This process is accomplished by placing resin into a hollow mold and then rotating that tool by actually in a oven. There is no pressure involved in this technique, unlike other plastic manufacturing process, thus making the mold cast cheap and the process economical. The mold is filled with a polymer resin and heated in an oven until the resin melts inside of the mold cavity. It is then slowly rotated to disappear and stick the soft material inside the mold cavity. A cool tool is used to solidify the parts and later the part is removed from the mold. Some examples of rotational molding include water tanks, medical products, consumer products, toys, aircraft sporting equipment. Then thermoforming. And thermoforming is a molding process where a plastic sheet is heated to an elastic forming temperature and formed into the desired shape. This method is often used for sample and prototype parts. It is divided into three types of manufacturing process, namely vacuum forming, then pressure forming and mechanical forming. Then the process, the thermoplastic sheet is heated using either convection or radiation until it gets softened. The soft sheet is then pressed against the mold using the vacuum or air pressure or mechanical force. The excess material is then turned away and the formed part is released. For example, some example of thermoforming include motor components, truss washers as cubes, valve and covers, disc brake, pistons, etc. And powder metrology. So powder metrology is a molding process used for manufacturing precision. So metal components from metal powders, the rate of production is parts is quite high in powder metallurgy, which makes it economical than the other casting process. A homogeneous mixture of metal powders or alloy powders is prepared. The metal powder is then pressed into the desired shape at room temperature. At last, the product is heated that causes the powder particles to fuse together without melting. For example, the powder metrology includes self-lubricating bearing, then porous metal filters, then gears, then cams, then brackets, sprockets, etc. Then forming. Forming is a manufacturing process that uses suitable stresses such as compression, tension or shear to deform the material and get the desired shape. This process involves deformation and displacement of material leading to no metal removal or loss of metal. The different types of manufacturing process under forming. Forming is a manufacturing process that uses compressive force to shape the material. This process is accomplished with the help of a hammer, press or a special forming machine. The forged parts have good strength and toughness without the defect of porosity. Inclusion or voids also can be used reliably for highly stressed and critical applications. Forging may be carried out on materials in either hot or cold state, and therefore it is divided into types of manufacturing process. For example, cold forging and hot forging. Then bending. Bending is a manufacturing process used to deform metal into the desired shape by using a die and punch. This process is most commonly used for sheet metal products. To get the required U-shape, V-shape or the channel shape. Commonly used bending machines are band brakes, brake presses and other specialized machine presses. Then the process is the material is placed on the die and positioned in place with the help of stops. The upper parts of the press with appropriately shaped punch attached to it descend and form the V-shaped bend. The U-punch form the U-shape with a single punch. Some example of bending operation include electric enclosures, electrical box, then brackets, then rectangular ductwork. And stamping process. Then the stamping or pressing is a manufacturing process in which then thin-walled metal parts are shaped dissolvable with the help of punches and dies. This process is accomplished by the placing flat sheet metal into a stamping press where a tool die and die surface form the metal into the desired shape. Then the stamping uses hydraulic or mechanical brush to perform the operations, which can be done at a single die station or multiple die stations. Also, this process is usually carried out on sheet metal, but can also be used on the materials such as polystyrene. And shearing. Shearing is a manufacturing process used to remove a blanket of required shape and a dimension from a large sheet of metal, paper or plastics. This process includes cutting of sheet without the formation of sheath or the use of burning or melting. Shearing is divided into following type of manufacturing process. So blanking, piercing, roll sliding, then trimming, then coining. There is the various shearing process. The punch applies press to the sheet, forming cracks on both the top and bottom edges of the sheet. The punch goes then further to grow this crack and eventually separate the slag from the material. For example, shearing include industrial machinery, automobile parts, electronic equipment, etc. Then machining. Machining is a manufacturing process used to cut pieces of raw material into the desired shape and size with the help of controlled material removal process. These processes are based on a common theme known as subtractive manufacturing. The machining process is used for all the types of product, especially metal products. The different type of manufacturing process under machining. Then milling is a process of removal of material from a workpiece using rotary cutters and getting the desired shape. Tanning operation. Tanning is a process of removal of unwanted material from circular parts using cutting tool. This process requires a lathe workpiece and a cutting tool. Then third one, shaping. The shaping process uses a cutting tool that reciprocates against a stationary workpiece, producing a plane or a desired surface. Then drilling. Drilling process uses a drill bit to make a hole of circular cross section into the solid material. Then honing. Honing process produces a precision surface on a metal workpiece by screwing and observed storm against it. Then finishing. Finishing process is used to improve appearance, then waterability, wear resistance, then hardness, or to remove wears and other surface flaws with the help of standards. Then joining or assembly process are part of every production process where two or more parts are combined together to get the required product. The main type of manufacturing process under joining. So welding process is used to heat and melt two or more parts and force them together, making a single functional part. So arc welding, resistance welding, then gas welding, and few types of welding operations. And soldering. Soldering process is also used to join two or more metal items by melting and putting filler metals into the joint. It differs from welding as it is does not involve melting of the workpiece. The brazing process is used to join two or more metal items together by melting and following a filler metal into the joint. The brazing uses higher temperature for a similar process as compared to soldering. Also, it requires punch more closely fitted parts than in soldering. Then adhesive bonding. Then adhesive bonding is used to hold multiple closely spaced parts together using a filler material called an adhesive. It is mainly used for a non-metallic substance such as polymer. Then mechanical assembly. It is a fastening process which uses nut, bolt and rivets to join the part together. It is also a reversible joining process. And types of lathe machines. Here various types of lathe machines have been used in manufacturing process. So first one, speed lathe machine, then center lathe or engine lathe machine, then turret lathe machine, then tool room lathe machine, then bench lathe machine, then automatic lathe machine, then special purpose lathe machine, then CNC lathe machine. So these types of various types of lathe. So first one, speed lathe machines. So the speed lathe machine is a high speed and hand operated lathe machine mainly used by woodworks. It can provide a spindle speed from 1200 to 3600 rpm. The machine comes with a very simple design. It contains heat test bed, tailstock, headstock bed, then tailstock and tool post. Due to their high speed spindle, then speed lathe machines are used for furniture, then woodworking, making, metal polishing, spinning and centering. That is a diagram of the lathe. Then center lathe or engine lathe. The engine lathe machine is the most popular type of lathe machine. We can find it inside any manufacturing workshop. Nowadays, the machine is driven by an electric motor, but back in the 19th century, people used steam engines to drive the machines. That's why it is called an engine lathe machine. Even those contain an engine nowadays, it is also called center lathe machine, because back then the almost all machine tools were driven by either separate engines or central engines. This type of lathe machine is used for woodworking and metalworking. You can perform various machining operations on this lathe machine, such as turning, facing, grooving, knurling, threading, drilling, boring, reaming and many more operations are to used in center lathe. And lastly, the machine is capable of hardening workpieces up to 1 meter in diameter and up to 4 meters in length. This is a diagram of the lathe. Then turret lathe machine. A turret lathe machine is an advanced lathe machine used for mass production. It is kind of an upgraded version of an engine lathe, where the tailstock is replaced by a revolving hexagonal turret. In this turret, you can set up multiple cutting tools. Usually up to 6 tools are to used in the lathe, such as drilling, then remaining, then tapping, etc. You see, this design makes your work a lot easier. All you have to do is simply clamp your workpiece in the chuck. Perform the first operation. Now rotate the turret and perform the second operation. You can repeat the process as long as you want. There are mainly three benefits of these machines. It reduces your workpiece load and unload times. Then yes, just clamp your workpiece once and perform as many operations you went in a single setup. You don't have to change tools every time you perform different operations. Just rotate the turret and you are good to go. It reduces human errors. You don't have to change the tool manually every time. Hence, it eliminates the chance of human error in tool alignment and machining operations. In tool room lathe machine. This is a special bed of lathe machine mostly used to make precision parts and tools such as die, cages, etc. Pictures it looks similar to an engine lathe machine, but it is made from more accurate and precise parts than an engine lathe machine. Thus, the price of a tool room machine is higher than an engine lathe machine. This is the diagram of the lathe. And bench lathe machine. A bench lathe machine is a small size hand operated power lathe mainly used for small precision work. It looks very similar to speed lathe machines. If you have a light job that requires lathe machine operation such as turning, facing, grooving, parting, threading, drilling, boring, knurling and tapping, etc. This machine is for you, but in general and what we use is machine a lot for the machining needs. In automatic lathe machines. And automatic lathe machines comes with a group of mechanisms that make it capable of changing and feeding cutting tools automatically. When you have a job that is complicated precisions, operations and requires skill and you have to produce it in mass quantity. This machine is suitable. This machine is heavy duty, production friendly and expensive. This is a diagram of the lathe. Then the special purpose lathe machines. You can guess by the name special purpose lathe. So machines are custom tailored lathe machines to suit particular needs. They are mostly used for the heavy duty jobs where regular lathe can be used or using regular lathes can be costlier or time consuming. And CNC lathe machine. CNC lathe machines are the most up-to-date lathe machines in terms of technology. They come with a modern computer numeric control system, that is a CNC. You can use this control system to add a CAD cam program, and after that whenever you command the machine, it will start and perform the machining operation according to your program input. So why studies manufacturing process? The designer and the drafter must have a working knowledge of the various processes that could produce a part in order to lower cost and reduce production time. So, three bases of the manufacturing process. So first one, product design and selection of materials, then selection of production. And three main stages of the production of machine part. Then rough forming, for using casting, forging, welding, then finishing, for example drilling, machining and surfacing, then assembling, the assembly of parts. The casting process or to machine manufacturing process. Then manufacturing materials fall into three general categories. So metal, plastic, inorganic metals. So metals are classified as ferrous and non-ferrous metals. So ferrous metal means contain iron and steel. So non-ferrous do not have iron content, such as copper and aluminum. So alloys mixture of two or more metals. So what is meant by alloy metals? So more than two different metals is combined in a single metals. That is a alloy metals. So composite materials means that is a same definitions. For example, more than two different combined in a metal is a composite materials. So what are the difference between the alloy and composite materials? So composite materials means more than two different metals is combined in a single metal. There is all the metals only for use for non-ferrous metals are used in composite materials. And alloy metal is more than two different metals combined in a single metal. At least one ferrous metals also used. That is the difference between the alloy and composite materials. So then carbon and graphite have low tensile strength ability. Then ceramic or clay and glass materials also used. Then heat treating. Then annealing is the process generally used to soften metal by heating followed by slow cooling. Then hardening requires heating and then rapid cooling in oil or water. And plastic processing. The plastic industry represents one of the major manufacturing segments, thermosetting and thermoplastic. So thermosetting plastics becoming permanently hard and enamel when subjected to heat. That is the thermosetting process. It is a no replacement using. But thermoplastics, once have to manufacturing on product, after that product will be reprocessing by using reprocessing in the object. That we are using the thermoplastic methods. That is the difference between thermosetting and thermoplastics. Okay, thank you.